Hi, I want to present our next presenter, Abhinav Singh, who's going to present his own tool, open source, right? Threat intelligence hunter. Okay.
Thanks. Hey everyone. So I'm here to talk about a tool that I developed around a year back. I still keep on updating because software is always needs some kind of updates. So this was more of an attempt for me to basically understand how we build a scalable solution. So quickly. So let's quickly begin with the presentation. I'll first start introducing myself. So I'm basically a security researcher and I do a lot of research and development around various security tools, technologies, and threats. I also authored a couple of books years back, and my editors, they just keep on revising it. I don't know why. Probably it's still doing fine, so it just gets revised every now and then. I also have a bunch of courses on Udemy related with exploit and pen testing tools. You can also connect with me on LinkedIn or Twitter. I'm pretty active there. So before I begin, I always introduce a slide about a place. Anyone can guess what place this is?
This is in
Yeah, this is.
Banana.
Yeah, that's right. So that's basically my hometown, Varanasi, and it's, I mean, mythologically it's the oldest city in the world. So if you guys probably want to visit it once in your lifetime, that would be something to look forward to. So basically, threat intelligence hunter is a tool that gathers intelligence from various sources. So before we go there, it's critical to understand what really threat intelligence is. So there are a lot of definitions which you can get about threat intelligence, but there were two which were pretty accurate, which I thought were worth mentioning. The first one is threat intelligence is composed of data and analysis, which gives you operational visibility. So what I mean by operational visibility is that, let's say, you have an operations team running where you want to give them direct insights. You don't want them to, the role of operations team is to work on insights, work on whatever inputs is given to them. There is a separate set of team who would basically collect that insight. So that's what threat intelligence comes under. It's basically a data-driven insight that you can give to your operations team. So there was another definition that says that threat intelligence is something that allows an organization to make better informed decisions with regards to its operational protection and response capabilities. So it's all related with threat response, how you basically use that data, how you digest it with your incident response team or your threat analysis team. So this is a good picture that I kind of found out. It very nicely and neatly kind of tells you what is the difference between bunch of data and what happens when it actually becomes intelligence data. So you have a lot of information coming into all your different security tools or probably whatever sources you have from where you collect your intelligence or data. Once you have the collection done, you kind of start processing it to derive meaningful information out of it. Once you have that meaningful information, you look at different other organizations, what kind of analysis they have on those particular account indicators. And once you have that kind of analysis done, you basically say that this is an intelligence data or a threat intelligence data. This like basically applies to any data that basically goes through this entire cycle. But because we are talking about threats, so this converts into a threat intelligence data. So what happens with threat intelligence data? What exactly organizations use it for, or how exactly it's beneficial? So it basically starts with the operations team, where you provide them the threat collected data. Then once the operations team takes certain actions, they will basically decide what to do next. Do they want to kind of have a policy set around those data, or do they want to have it shared with their legal team and stuff like that? So I'm not sure why this keeps getting this. All right, so once you have your legal team involved, you can further have your information security advisory board involved with that data. If let's say you come up with a targeted attack that was particularly designed for your organization, then you obviously want your information security team to have involved your CISO boards where you tell them that, okay, this is something that we are seeing in our network, this is how we should tackle it, and basically what should be the next steps. Basically, once you do that, enterprise risk management is something which I personally feel that it should come before legal. So basically, let's say you had some kind of vulnerability because of which the threat came into your network, then it's the enterprise risk management team that should take care of the vulnerability first, compared to the other teams that gets involved. Last is the fraud department, which comes in, let's say, some data exfiltration happened, your PII data got lost. So that's where the fraud teams comes into action. That's where they kind of build their own intelligence. So everything basically, so this is a cycle, but everything results into an intelligence data. Let's say some data exfiltration happened, and what are the insights for that data exfiltration? What tools did the attackers use? What were the TTPs and stuff like that? So that's the kind of information that you gather along, and that's what becomes the threat intelligence. There is a very interesting angle to threat intelligence. It's called the pyramid of pain. I have it in my notes who basically coined it. I think it was David Bianco. It's worth mentioning his name because he's the one who coined this pyramid. So what exactly is happening here is the IOCs. So in threat intelligence, we have a lot of atomic indicators. For example, we have IP addresses, we have domains, hashes, and things like that. So how do they basically layer up? For example, if you look at the bottom, it says that hash value. It's very trivial information. It's not a rocket science to basically change the hashes of files. It's pretty straightforward. You change one variable name in the binary, that's it. That should be more than enough to kind of have a new hash generated for you. So it's not something that is really very useful unless you have more information to kind of build on top of it. That okay, this was the hash which connected to this IP, and this was what happened with that particular server. So after hashes, we have IP addresses, which is relatively easy to figure out, and it's easy to change it as well. Once an ISP blocks an IP address, the attacker basically switches to the next IP address. Then you have domain names. There is a harder scrutiny on registering a domain name. It's not easy to register, let's say, Apple.com. You'll have to figure out some ways. You have to think of creative ways to register domains which doesn't look kind of stealthy. Sorry about that. So that was the I think it's not able to remain at this screen. Anyways, I'll keep the mouse moving. Okay, so now that we have some insight on what threat intelligence is, I'll quickly talk about what is threat intelligence control. So, as I said, it was a tool that I developed and I wanted to really understand how to build a scalable solution. And it's on GitHub and Peerlyst as well. You can go ahead and look at it as well. I have a plan to quickly go through the source code as well because I don't want it to be a slide-driven kind of presentation. If, let's say, any of you are interested in understanding how we kind of build these kinds of tools or have a basic understanding of, let's say, if you want to attempt something, then what should be your directions. So what exactly the tool does is that it basically gathers all the atomic indicators which we saw in the pyramid tool from various open sources. For example, there are a lot of sources on the internet which provides you with daily feeds of IP addresses, hashes, and we also have Aristotle where you can query domains and hashes, and you can gather that information. So what PIH does is that it basically aggregates all those sources into a single tool, and you just have certain command lines which you can use to basically look at what's the reputation of a hash or what's the reputation of a URL or whether an IP is blacklisted or not. Sorry. So There's a GitHub link where you can start. I'm so sorry. I don't know what's wrong with the sample being project too. For some reason. Okay, so we were here. So that's the GitHub link from where you can have a look at the tool, and I posted a Peerlyst post as well on the tool where you can. I mean, it basically has the source code which is quoted from GitHub. It's based on MIT license, so you have following permissions. You can have it in commercial use, and there is one which I know where the tool is already being used. You can modify it if you find some new modifications to it, or if you want to add some new features to it. You're free to distribute as well once you have it modified. You can use it privately as well if you don't want to really share it with anyone. What are the limitations? Is that there are no liabilities associated with the tool, and there is no warranty. It's an open source tool, so you can use it at your own will. So there is a Jenkins build job as well, and as of now it's running fine. There are no errors in the code. There were few, and I kind of worked on to fix them. And the best part with open source tools is that a lot of communities, they kind of, when they start using the tool, they start coming up with new vulnerabilities or basically problems with your code which you might not figure out when you are building it. So that's when they start raising questions that this is not working, that is not working. And that's the beauty of open source. You can go ahead and improve your code every now and then. So what are its features? The first one is that it provides you the local storage for thread feeds. You can create your own local database, and you can just kind of have, because all these open sources from where TIH is gathering the intelligence, they are updated on a daily basis. So you can create your own local database where you can keep adding feeds every day. It basically helps you build your own database to collect all the atomic indicators from various sources. You can also check for IOCs against the current published feeds. Let's say you have an IP address, someone gives you the IP address and they say that this is something suspicious and it's trying to communicate with something outside. So what you can do is that you can use TIH to use your IP address and search if it's already being mentioned in any of those open thread feed sources. You can also provide a list of IP addresses, because a lot of times you get like 50 or 100 IP addresses to look for. So you can create a text file, you can dump all the IP addresses there, and you can just have it quickly search across. The same goes with MD5 as well. You can either search for a single MD5 across different sources, across VirusTotal, and it will tell you whether that hash has been ever blacklisted or if there are any security solutions work out of it. I have added a URL blacklisting. Well, this was a feature which was requested by someone, so I just added it. So you can basically query for URL, basically what's their reputation, whether they have been blacklisted ever, and it uses URL Void, which is a very popular URL reputation service. All you have to do is just create an API for yourself, provide the API key to the code, and that's how it works. I'll go through those things. Pretty simple requirements, nothing too fancy. We just need Python. Artparts is something that's a Python library. It comes with it basically comes with the OS library of Python. So it basically takes all those arguments that you can pass to the command line. So that's what our class helps you with. Request is something that helps you raise API queries. And the last, you need API keys from VirusTotal as well as URL void. Let's say if you want to query the data, if you want to use VirusTotal for hash lookups or lookups, you'll have to get an API key. For VT, it's free for 4 queries in a minute. If you have a paid account, very good, you can use it more than 4 times. If you don't, then for free, VirusTotal gives you basically 4 queries for a minute. If you have more than those, you'll have to wait for a minute before you confirm the next one. So there were some common errors. I'm not sure if that's clearly visible, but there were some common errors which I faced when I was developing these tools, or when others basically started using the tool from GitHub. So they reported a lot of ways. One of the common ones is to make sure that you always add your API key, your VirusTotal as well as your API key. Just go to the website, generate your API key, and add it to the code. I'll show you the location where we do it. The second one is, let's say you're working in a corporate environment, and definitely there will be a proxy. So you can basically provide that information to the tool, and it will connect to the proxy, and all your requests will start working fine. All the dependencies that we mentioned here, they all can be installed by just passing this command, install. It basically pulls out all the requirements that I have mentioned in the text file, which is there on the GitHub and Peerlyst. You can pull those requirements and you can start using the tool right out of the box. So as of now, I have around 14 queries that were raised by people from different parts, and there were some interesting ones. There were some normal ones like missing APIs and things like that. So that's one of the advantages when you build up an open source tool, or when you build something which is for the public. You start getting a good feedback from your tool. You start learning how others are using your tool, and that's when you start kind of improving on what you have done. So that was all slide. We can quickly jump to how we use it. So I'm not sure if that's entirely visible. Okay. Let me see if I can increase the resolutions on. I think it's slightly better. So the first feature is to look for an IP address. So if you look at the first command that I passed, it says Python PIH.py followed by IP, which is the argument that we're passing if you have to look for an IP address, and then there is an IP address. So what the tool does is that it basically starts connecting with all the different open sources, the thread feeds that we have. It starts looking for that particular IP if it exists in any of these feeds. And if you look here, we have a match which says that this feed was found in manco.com. So that's how it tool works. Basically, it starts looking at all these open feeds and it tells you whether there is a match or not. Something similar happens when we provide a list. So if you see here, I passed a text file, and the text file basically contains multiple different IPs. So whenever there is a match, it tells you that, okay, the IP address that was there in the list has been found to be matching in one of those feeds. We also have an MD5 lookup as well. So right now, how MD5 works is that it basically goes to VirusTotal, picks up the hash, it queries, and it tells you how many engines are basically detecting that particular hash. So in this case, the hash that I have added here, it's a Zeus binary. This hash is basically detected by 38 vendors out of 60. So that's how VirusTotal provides the information. We can provide multiple hashes as well, but one thing to note here is that if, let's say, you're using a free VirusTotal API, then you have a limitation of 4 queries a minute. So if you want to provide a non-separated value, it should not be more than 4. If you have a paid account, definitely you can use as many as you want. And again, you can have a text file with all the hashes. You can dump it here, and TIH will go ahead and fetch from VirusTotal always. So whatever detections are found, it basically result here that, okay, 38 engines detected it or 11 detected it. Then there is something for URL as well. It's kind of generating a traffic. Anyways, it queries for URL as well. You can provide the URL, it can go to VirusTotal and URL Vault, from where it can give you the reputation or how the engines are basically saying that the URL is bad. For example, in this case, this URL is detected by 3 engines, and whatever is the reason, we can further go ahead and make different API queries to figure out why or what are those 3 engines which are saying that the URL is bad. This one is about reputations. So in this case, we have provided a parameter repo. So once you have the repo parameter there and you provide the URL, it goes ahead to URL void and it fetches the reputation. The reputation is about what the domain's age, when was it registered, what does Google rank it as, what does Alexa rank that domain as. So these are some of the indicators which tell you whether that domain is bad or not. And the last one, which most of the people have found the most useful, is the local storage of the head. So what you can do with TIH is that you can create your own local storage, because all those open source feeds, they kind of repeat, not exactly repeat, they basically append new data every now and then. Like let's say for some feeds it's 24 hours, for some it's 8 hours, for some it's 48 hours. So with TIH, you can schedule a job and it will regularly fetch data from those feeds and it will store it locally for you. So if let's say you have already created a database, all you have to do is pass the update parameter and it will again go to the sources. It will pull up all the data from there and it will regularly keep on updating your local storage. So that's how TIH basically maintains a database. As of now, I think I have around, if I exclude VT and URL Void, I have around 25 odd open source feeds from where it collects the intelligence. When I started, there were around 36, but some went down. They don't respond now, and I have to remove them. So this is how your local storage would look like. So the tool will create a directory for you called Intel, and within the Intel, it will create some directories with the name of the thread feed from where it collected the data. For example, the Zeus tracker IP feed, and it will create a text file with all the IPs that it fetched from there. And if you look at it, all those text files are based on dates. So every time a new job runs, it will create a new text file and it will save it with a new date. So it makes it easy for you to judge like which text file or when was the feed collected. We have a few more down here. Locklist, emerging threads, which is pretty good. Most of the time I find something matching in emerging threads. And there are some poems, IP feeds, malcodes, malware domain list, that's also pretty helpful. Project Honeynet, that's pretty good for latest IPs. We have some Tor exit nodes IP as well, which a lot of organizations find helpful if they want to disable Tor in their network. So that's how the tool works. So one important question is, I'll bring it on a full screen because it's important. What can we do further with the tool? So as of now, the tool doesn't go back and look into the database that it creates. You can obviously use Linux to do it. You can just do a grep and run, and it will basically give you the result. But I feel that we should have it inbuilt in the tool as well. It should go and it should look in your. One thing which I really want to add to it. The second one is support for standard formats like sticks, taxi. Anyone familiar with it? Sticks and taxi. So this is basically an open thread information sharing format that was developed so that, because you have a bunch of security tools, they all have their own way of collecting threat intelligence. They have their own way of reporting it. For example, if you have an antivirus, it will give you a detection name, file hash, when was it created, when was it updated. If you have an intrusion prevention system, it will be about IP addresses, when was it seen, when was it registered, and stuff like that. So Sticks Taxi was a standard information that was created so that all security tools follow this protocol to create a generic information. It becomes easy for other tools to digest that information. So that's what it is. I want to add this feature to TIH so that whatever information we are saving as a local database, it should also be consumable in the form of sticks and tags. This was a request that actually came from one of the smaller companies, I would say. They are based in Asia. And they use the tool to collect intel from all these sources. So they said that it would be great if we had an option to export information in sticks. That's why I've added it in the future development. Front-end UI, everyone loves UI. If you have one, then that would make life easier for others. Even though it's an open source tool, that's too much of an effort to add an UI. But yeah, I mean, it's good to have a front end from where you can make it easy for others to gather information. Multi-threaded search. So I've been using it for quite some time. I have a very extensive database that I built using this tool. And over the time, the database has grown a lot. Like, it has millions of records now. If I run a search, it takes time. It's not as fast as, like, if I run a grep, it completely depends on my system's processing now. So I want to make it multi-threaded. If we can search by creating different threads, so that it's way more faster. But that will only be done if I add the first feature, like search for indicators in the local database. The last one is adding more integrations. If, let's say, you find out a new open field which has a very valuable information, and if you want to use it inside the tool, then you're more than welcome to just add it here. So that's about the tool. Before I open for questions, any of you, do you want to see a demo, or
Sure.
do you look at the code? Actually, that I feel code would help a lot. If I know how to exit from here.